Okay, here we are. We're going to continue our topic of analytical trigonometry, and we're going to discuss about trig identities in this section. Our main discussion will be about what is an identity, and we're going to review some of the fundamental identities before we begin our main topic. So let's begin. So what is an identity? Well, two functions f and g are said to be identically equal if f of x equals g of x for every value of x for which both functions are defined. So one of them may not be defined at certain values of x, but the other one might be. Okay, but as long as they are defined, both of them, they will have the same value. That is what it takes to be an identity. Such an equation is referred to as an identity. An equation that is not an identity is called a conditional equation, which is what you're most comfortable with working with. When they say solve this equation, when we say solve trigonometric equations, those are conditional equations, which basically means it's only true for certain values. It's not true for every value. It's just true for certain values, and it was your job to figure out what those values were. That's why we were saying solve this equation. These are conditional equations. That's not the case here. The case here is they're true everywhere, and you have to prove it. You have to show that they're equal. So that's what an identity is. Now next thing we're going to do is review some of the fundamental identities that we're going to be needing to know and use them a lot. You've already had these already. Just want to familiarize yourself with them once again. So remember the quotient identities. The tangent of theta is the same as the sine of theta divided by the cosine of theta. And the cotangent of theta is the cosine of theta divided by the sine of theta. And remember the reciprocal ones. Cosecant of theta is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Okay, so you needed to remember those identities. And then we have the Pythagorean identities. Sine squared of theta plus cosine squared of theta equals 1. Tangent squared of theta plus 1 is secant squared of theta. And cotangent squared of theta plus 1 is equals to the cosecant squared of theta. So those are the fundamental ones that we picked up at the very beginning when we were talking about trig functions, and we proved them. Now this next one is ones that we kind of picked up toward the end, the even and odd identities. Sine of negative theta is the opposite of sine of theta. Cosine of negative theta is the same thing as the cosine of theta. The tangent of negative theta is the same thing as the negative tangent of theta. So these are identities that you just need to know and use them. If you struggle with these, you're going to struggle with the proof of identities, because you have to show the left equals the right side or the right side equals the left side by using these identities here and algebra. If you're weak in either one of those, this will be very problematic. So you've got to know how to replace something with another trig function by use of other already used identities. And, which probably is a little bit more importantly, the algebra itself, being able to manipulate expressions from one form to another form. The manipulation is the algebra aspect, and to be quite honest with you, most students probably have more trouble with that than the trig itself. It's the manipulations is where most students will struggle with that. To get past that, the trig identities you can look up until you've got those memorized, and you usually can get by. But proof of trigonometric identities in itself is probably the most complicated thing that you'll ever do in this course. That's not to say it's probably the hardest thing. It's just more algebra and more trig that you have to do. So there's more different things you have to do. As overall, it's just a movement of terms from one to another to make it look in a different form. So if you have any questions on this review and what an identity is to begin with, let me know, and we'll go from there. And you have a good day.